Hey Math 1B, had a few requests for 8.4 to have a video made on that, so here we go. I'm just going to do the first 4 problems from the notes, and you guys really aren't expected to do 5 and 6 on your own. I did post somebody else's YouTube video on that though, and you can get extra credit for doing that part of the assignment. Anyways, 8.4. So a couple things to keep in mind. If you're trying to add or subtract roots of different values inside here, you actually need them to become common roots. All right? So what I'm saying is root 50 plus root 18 does not equal root 68. It doesn't work. I mean, I could very easily verify that. I could say on my calculator, root 50 plus root 18. Hold on. Syntax error. That means I messed up. Okay, got it. The top one is 11.3. The bottom one, there's no way that's 11.3. That's 8.2. Okay, so I instantly found that you can't add these two under the root. So finding one that doesn't work means like you just don't have that rule, period. So here's what we got to do. We need to simplify each individual root first, okay? Then if the number underneath matches, we actually can do some combining. So I need you guys to do factor trees for 50, factor trees for 18, 75, and 27, okay? So that's 2 times 25, and that's 5 times 5. The way we've talked about it in the past is if you've got pairs of factors inside of a square root, that square root of 5 times 5 is 5 on the outside and root 2 on the inside. Root 50 is 5 root 2. Next one, you can cut that in half, 2 times 9. You can cut that by 3. Root 18 is 3, and it's positive 3 because there was a plus there. Root 2. We do the same thing with these others. So 75, I can't cut it in half, but I can cut it into 3. 3 times 25 is 75. 5 times 5. So I'm going to have a minus 5 that comes out of the roots. And then the 3 is the thing that's left over. And then 27, that's 3 times 9, which is 3 times 3. I can take a 3 out because of the pair there. It's going to be plus 3, and then this is going to be inside of the root, root 3. So notice, everybody who did not have a pair to take out is going inside of the root. Now here's the deal. Once you get square roots or any roots with the same, I think it's called the radicand. I'm not going to call it that. I'm just going to call it the number inside the root. Once the number inside the root's the same, then I can say 5 root 2 plus 3 root 2 is 8 root 2. And again, I can go off to the side, plug this into my calculator, just to confirm that that rule at least works with this one. So let's do that really quick. 5 root 2 plus 3 root 2. I did the same error again. Wow, okay. Sometimes technology can be frustrating. But we carry on. Okay, 11.3. 8 root 2. Also 11.3. It works for this example, and it works for all other examples. So, you can proceed with confidence now. Same roots. You just take negative 5 plus 3 now, and you get negative 2 root 3. And that's your simplified answer. Okay, all right. Let's try number 2 now. Pretty much the same thing, except I put a couple coefficients out front there. Not going to be a problem. We're just going to let those hang out in red right here and do what we did before. So I'm going to break down 80. I'm going to break down 20. And I'm going to break down 180. And I'll do it relatively quickly because, again, the time's ticking on this video, and I don't want the factor tree to be the thing we focus most of our time on. 240, 220, 210, 25. Which means 2 goes on the outside of the root times 2 goes on the outside of the root, and then the 5 is left over. So that's 4 root 5. Over here, 20 is 2 times 10, which is 2 times 5. Now this is where it gets tricky. I've got 2 on the outside of the root with a 5 left over inside of the root. But that negative 3 doesn't just go away. The negative 3 is in front of root 20, so the negative 3 is in front of 2 root 5. The operation that's happening in between them? Multiply. So then right away I can say, okay, this one right here, I'm going to put the plus 2 so I don't forget about it, because usually students forget about these things if they do make a mistake. All right, 180 is going to get broken down into 290, 245. No more 2's. 3 works. 315, 35. All primes, so now we say a 2 comes out of the root, a 3 comes out of the root, and then there's a 5. Didn't have a pair, so it stays inside. So pause the video and ponder that. See if you can wrap your mind around how roots work, where if you take pairs outside of, because think about this, the square root of 4, 2 times 2, is 2. The square root of 4 is 2. The square root of 4 is 2. Okay? The square root of 9, 3 times 3, is 3. So that's what I'm doing with these pairs. That's why I'm taking them out of the roots. I'm computing those square roots. At any rate, what we're going to do now is actually say negative 3 times 2 is negative 6. And 2 times 2 times 3 is 12. They're all root 5s, so you can just combine all the coefficients for each one of them. So you can do 4 minus 6, which is negative 2, plus 12, which is positive 10. So it's positive 10 root 5. All right, on the second part, you're asked to do a skill that requires some baseline knowledge of the double distributive property. Sometimes you may have heard it as FOIL. All it means is that if I'm multiplying 2 quantities, okay, in which I can't simplify the inside of the parentheses, there's nothing much we can do here, there's nothing much we can do here. What I can do is use a little bit of separation. I can say, hey, this root 5 needs to be multiplied by everybody over here. So I'm going to do a rewrite. I'm going to say root 5 is going to be multiplied by everybody in this second group, because this multiplication here has to be honored. Okay? Root 2 plus root 6. But then we also need this negative root 2 to be multiplied by everybody else in the other set of parentheses. So over here, I'm going to put negative root 2 times, which the parentheses take care of that, times root 2 plus root 6. All right, and then what you got to do is recognize, okay, how do I use the distributive property here, and how do I use the distributive property here? Well, root 5 times root 2 is the first computation you got to do. Same root, as far as it's a square root here and a square root here. You can just multiply these two numbers and call it root 10. Here, you're going to get plus root 30. Okay? Over here, you're going to get minus root 4. And over here, you're going to get a negative times a positive minus root 12. Now it looks like something from above. 1 and 2. Can you simplify this? So we factor tree here. We got nothing. That means it must stay as root 10. Can't break down. 30. You got 215. You got 3, 5. No pairs. Nothing. So it stays as plus root 30. These two cannot combine with one another. Now root 4. Root 4 is 2. But if you fail to just recognize that right away, it'd be 2 times 2. You can take a 2 out, and it's negative. But there's nothing inside the root. If there's nothing inside the root, you just have to sort of say, no root needed. It's just 2. And, I mean, let's use practical wisdom on this, right? If I type the square root of 4 in my calculator, see, there's no root. It's just 2. 2. 2. Okay. And then the last one, 12. This is 2 and 6. 2 and 3. We got a pair of 2's that come out. So it's minus 2 on the outside, and then root 3 is going to be left over inside. Since none of the roots have a same inside, I can't add or subtract them together. All right, last one. I gotta move quick because the bell's gonna ring here soon. Do the same thing you did over here. In fact, why don't you pause it and try the first couple steps on your own. All right, let's see if you did it. So this guy has got to be multiplied by everybody in the second group. So I'm just going to rewrite it, put side by side with. Visualizing the distributive property usually works better that way. And then in green, I'm going to go over here. Negative root 45 is going to be written side by side with root 12 plus 2 root 6. Because it's got to be multiplied by everybody too. So now, if there's a number on the outside, but no number on the outside here, that's okay. That just means we're going to have 2 root 36. I'm multiplying the 3 times the 12 on the inside only. Okay? And then here, I'm going to have 2 times 2, which is going to be plus 4. And then root 3 times root 6 is root 18. Over here, no outside number to contend with, so it's just going to be minus root. 450 times 12 is going to be 540. And then here, you got a minus, but a plus 2, so it's like a negative 1 almost. Kind of on the outside if they don't put something in there. Negative 1 times 2 is negative 2 root 270. Okay? 45 times 6 is 270. All right. And then you just break them down. So I know that the square root of 36 is 6. So this one's going to end up with no root at all. But if you do it the old-fashioned way, the long route, you'll find that there's a 2 on the outside of the root times a 3 on the outside of the root. Don't forget that 2. And then since there are no leftover terms, you do not put a root. Root of what? There's none, because there's no leftovers. So 2 times 2 times 3, it's 12. Here, you got your 18. Break it down. 2 times 9, 3 times 3. Take a 3 out of the root. Put a root 2 inside. And don't forget the plus 4. Plus, that's 12 root 2. 12 root 2. And then there's a plus 12 here, so don't forget about that. Over here, 540. Got a lot to break down here, so cut it in half. You get 270. Cut that in half, you get 135. Can't divide by 2, but you can divide by 3. It's 45. You can divide by 3, it's 15. You can divide by 3, it's 5. Okay. So a 2 comes out. A 3 comes out. The minus stays, and you're left with a root 15. So it's going to be minus 6 root 15. All right, then the last one, breaking down 270. Ooh, we're approaching 18 minutes. I got to wrap this up quick. 270 I've already broken down over here, so I'm just going to kind of copy my work. Looks like we got a pair of 3s. Oh, thanks. That's it. So a 3 comes out. There's still a minus 2 outside, so bring that down as well. And then there's a 2 and a 3 and a 5. It's 30 inside the root, which ends up being minus 6 root 30. Okay. Root 2, root 15, root 30. They're not the same. I can't add or subtract any of them to one another. A sad day in Mathville, but that's okay. Because as long as we understand that you can't combine it, that's my goal. That's what I'm getting after. All right, guys. Hey, you endured a 19.5-minute video. Props. Good luck on the homework.